This is problem 16 through 20 on the multiple choice review. Okay, we have 2x to the 2/3 minus 5x to the 1/3 is equal to 3. Well, the big thing I've got to realize, this is basically a quadratic in form. So what happens here is x to the 1/3, when I square it, I get x to the 2/3. So I'm going to let u equal x to the 1/3. That means u squared is x to the 2/3. So I've got 2u squared minus 5u equals 3. I'm going to solve for u and then go back and then figure out what x is. So move everything to one side. 5u minus 3 equals 0. 2u, u. There's not very many possibilities, so I'm just going to go straight to this, not bother using a rectangle. Okay, I need two numbers. When I go over using the 2 right here, I'm going to get -5. So if I use -3 over here, that will give me -6 and 1. Because only one way of getting 3 is 1 times 3. If this didn't work, I'll try 3 here and 1 here. Okay, I need to get -5, so if I make this one negative, that would give me -6u plus 1u. So that gives me -5u. So we have 2u plus 1 equals 0, u minus 3 equals 0, 2u equals -1, u equals -1/2, and I get u equals 3. Okay, now I'm going to come back up here. If u equals -1/2, and we said u is equal to x to the 1/3, if I want to get rid of x to the 1/3, I've got to cube both sides. So the cube of -1/2, if I cube this, multiply it by itself 3 times, so it's -1/2 times -1/2 times -1/2. That is -1/8. If I use the 3, 3 is equal to x to the 1/3, cube both sides. 3 cubed is 27. So my answers are 27 and -1/8. Okay, we have a piecewise defined function on number 17. So we basically just got to find two equations. Now I got to look at where my transition point is. My transition point happens at x equals 1. So if you want to save yourself some time, you could cross off anything that doesn't have the x equals 1. Okay, so you may see it where it's already going to have those. You may not be able to have that as an option, but it is a strategy for doing some multiple choice. Okay, now for the parabola, I still have two parabolas chosen. I'm still using less than, so I just got to know what I'm working with. I can see it's upside down. Well, they're both negative. This one is to the left 1 and up 4. Remember, shifts left and right work opposite, so this would be x plus 1. Now for the square root, it's got to be this because that's the only thing that's left, but this is kind of verify it. It is right 1, so that's x minus 1, down 2, minus 2, be b and e. Okay, question number 18. Okay, work with our rules of exponents. This is kind of a nasty looking one. You just got to take it really slow. So, first of all, I'm going to start rewriting these things all into powers of 2. 2 goes to all of these. So it's 2 to the 5th. This is 2 to the 3rd times x minus 2. 2 to the 4th times x plus 1. 2 to the 1st times this one. 4 is 2 squared. So it's 2 to the 2x. And then where radicals, it's going to give us a fraction. So it's 2x over 3. Still got to deal with this guy. Okay, this is the same as 2 to the 5th times 1 over 2 to 3x minus 2. So that means I've got 2 to the 5th times, I'm going to change this to a multiplication problem, 2 to the negative 3x minus 2 times 2 to the 4x plus 1, 2 to the first, 2 to the 2x over 3. Now I need to combine all these. So when I multiply, I add my exponents. So I've got 2 raised to the 5 minus 3x minus 2 plus 4x plus 1 equals 2 raised to the 1 times 1 plus 2x over 3. Now I've got my bases to match. Now I can set these equal. So I'm going to multiply this out, just distribute the factors, and then we'll look at solving it. So I've got 5 minus 3x plus 6 plus 4x plus 4 equals 1 plus 2x over 3. I'm going to simplify over on this side first. So I've got 4x minus 3x, that's x. I have 11, or I could do even easier. I have 10 plus 5 is 15. Equals 1 plus 2x over 3. I'm going to subtract 1. You could use fraction busters at this point if you wanted to. Equals 2x over 3. But I'm just going to actually put this over 1, cross multiply, it'd be the same as doing fraction busters. So 3x, 3 times 14 is 42. Equals 2x. Subtract 3x, I get 42 is equal to negative x. So x equals negative 42. So that'd be my answer. Okay, next one. Looking at your answers, you can see that you have to use a quadratic formula. Okay, so remember, negative b plus or minus square root of b squared minus 4ac all over 2a. You have to have that memorized. Okay, b is negative 4. So I got 4 plus or minus. When you take negative 4 and you square it, best to do it in your head. Negative 4 squared is 16. Minus 4 times a was 2. C was negative 1. Over a was 2. So that's just plugging in. Okay, so I've got 4 plus or minus square root of. We have negative 4 times 2 is negative 8 times negative 1 is positive 8. Watch out for canceling here. You cannot cancel those 4s with the plus and minus there. Okay, 16 plus 8 is square root of 24. So now I've got 4 plus or minus the square root of 24 over 4. I need to simplify this. So what I like to do is think about perfect squares that will go into this. Well, 4 will go into that. 4 is 2 squared. 4 times 6. So this is 4 plus or minus the square root of 4 times 6 over 4. Square root of 4 is 2. Now I look at all three of these terms. 2 goes to all of them. Or I could factor out a 2 out of this and then cancel with the 4. I got to only cancel cross multiplication. But if I look at all the terms and I divide them all by 2, I get 2 plus or minus the square root of 6 over 2. So I'm looking for which one of those answers match, and that would be D. Okay, solving inequalities in one variable. We're going to work with the absolute value right here. So, easiest thing to do a lot of times is to go over and just simply change this to an equals and then solve it, and then we're going to do a number line. So I'm going to subtract 9 at the same time. So I get negative 39 equals negative 3. 3 minus 2x. Divide by negative 3, I get 13 equals absolute value of 3 minus 2x. Now we check. If I have the absolute value equaling a negative, it's one of our special cases. That's the all numbers or no solution. Then I just got to test any number I want. Usually I plug in 0 to see if it's true or false. If it's true, it's all numbers. If it's false, it's no solution. This is not a special case, so I'm going to do the two different cases. Either it's going to be 13 equals 3 minus 2x, or it's negative 13 equals 3 minus 2x. So I got 10 equals negative 2x, and I have negative 16 equals negative 2x, negative 5 equals x, 8 equals x. Okay, so now I'm going to take this information and I'm going to put it on a number line, and then I'm going to test it. We have negative 5. Don't have equals, so I'm going to do an open circle. We have 8. Open circle. Now you can go and test each of the regions to see if they're true or false. But it's either going to go true, false, true, or it's going to go false, true, false. So I just need to kind of find out what one of them is. The only exception to that is when we have a repeat of factors. So that happens with quadratics. You got to be a little bit worried. If you get the same number twice, then you got to worry, because then you get repeats. But if they're all different, you should be changing signs. That's going to happen on the absolute value as long as it's not one of these special cases. If you make a mistake on the special cases, you could test all the regions. They're all going to be true or false. So it would be safe to kind of go through that. And it's not bad to go through and test it. But I'm just going to do it with 0. If I plug in negative 30 greater than 9 minus 3 times, if I plugged in 0, I just get 3. So I get negative 30 greater than 0. That's false. My true stuff is going to be the other sides. Now you can go and test some points. Plug in easy numbers as you can. Use this the next number over. I could plug in like negative 6. Then I get 3 plus 12. And then that'd be 15. It'll be right here. Times 3 would be 45. So 9 minus 45. That will be less than negative 30. Or I can plug in maybe 10 in this. Try to see what you have. The numbers get kind of big sometimes. But I want the truths. So it's going to be x is less than negative 5 and x is greater than 8.